Hey everyone, I'm going to be talking about geometry, specifically circles and their qualities. So angle measure AD and angle measure CG are diameters of point B. Identify each arc as a major arc, minor arc, or semicircle. Then find its measure. So I'm going to be explaining what the circle means. B is the center of the circle, and all points on the circle are the same distance from B. Therefore, points A, C, D, F, and G are all points on the circle. So it's been agreed upon in math that if you go around an entire circle, it's 360 degrees. So in our figure, we can see that from C to D is 55 degrees, and from F to G is 35 degrees as shown. But we should also notice that from C to G along the circle, you're going exactly halfway around the circle, which is 180 degrees. So based on what an arc is, I'm going to be showing you what the definition of an arc. So a central angle of a circle is an angle with vertex in the center of the circle. Its sides contain two radii of the circle. Angle measure ABC is a central angle of point B. So now that we're back to the circle, we can see that arc CD, is a measurement of 55 degrees. But let's say we're going around the circle from point C counterclockwise to point D. We'll call the arc CAD. So to make sure the two arcs are different, we'll add a point to the name of the arc, F to D counterclockwise. But finally, let's define the three different types of arcs. A minor arc has an angle measure between 0 and 180 degrees. For example, if FG is a minor arc because it's between 0 and less than 180 degrees. A semicircle is an arc that has an angle measure of 180 degrees. So in our figure, C, A, and G is a semicircle because it's half of 360 degrees because it's not an entire circle, hence it goes halfway around. And lastly, a major arc has an angle measure above 180 degrees, but less than 360 degrees. But now let's solve our problem. The measure of CFG is a measure of half a circle, which is 180 degrees. Therefore, it's a semicircle. And now I'm going to show you our new problem. So it's asking us to find the value of x on line PQ. So in this figure, M, N, P, and Q are all on the circle. The straight line from MN is a chord length of 26, while 3x plus 5 is a chord length of PQ. So we can say a chord of a circle is a straight line segment that connects two different points on the circle. We should also notice on our figure that MN has one tick mark, while an arc PQ has one as well. So we can conclude from the figure that the angle measure of MN is equal to the measurement of PQ. But let's look at theorem 11.2 to help us out. In the same circle or in the congruent circles, two minor arcs are congruent if and only their corresponding chords are congruent. So, in other words, if two chords are congruent, then their minor arcs are also congruent. So the converse of theorem 11.2, which is basically the opposite of what the theorem was saying to us, is that the same circle, minor arcs are congruent, and their corresponding chords are also congruent. Now we're also actually going to use the converse of theorem 11.2 to solve for a problem, but in this case, to find the value of x. So as we also mentioned in the beginning of the presentation, using the converse of theorem 11-2, we can say that arc MN is congruent to PQ. Then the chord from point M to N is congruent to point P to point Q. So since we know this, we can write the equation. So 26 equals 3x plus 5. So we're trying to isolate x. So in this case, we should subtract 5 from both sides. So in this case, 26 minus 5 would be 21, while 5 minus 5 would be 0, so that would be left with 3x. So 21 equals 3x. But we need to have x reduced. So we're going to divide both sides by 3. So in this case, x would be equal to 7, because 3 times 7 is 21. So let's get started on our next problem. We're asked to find each measure, but in this case, find the measure of GH. So using the principle of adding arcs to make a bigger arc, the arc of GHJ is a semicircle, which means it's equal to 108 degrees because it's half of 360 degrees of the whole circle, which I said many times. So, but we're going to talk about definitions of involving this circle. An inscribed angle is an angle formed by two chords in a circle which have a common endpoint in the circle, which is G. So HGJ in our figure is an inscribed angle, with GH and GJ being chords in this inscribed angle. I should also mention what an interceptor is. For example, HJ is the arc intercepted by the inscribed angle HGJ. HJ is the arc between the points where the chords of the inscribed angle touch the circle. So now let's refer to theorem 11.6. So theorem 11.6 says, if an angle is inscribed in a circle, then the measure of the arc equals 1/2 the measure of the intercepted arc. So we know that measure of HJ equals 2 times the measure of angle G, which is 4C. So measure of GH equals the measure of GHJ minus the measure of arc length of HJ. So the measure of arc GHJ is 180 degrees, while the measure of arc HJ is 40 degrees. So when you subtract them together, it would make it 140 degrees. So now our problem here is asking us to find x, and we're assuming that the segments appear to be tangent are tangent, and we're asked to round to the nearest tenth if necessary. So because of this, J is the center of our circle, obviously, and point G is outside the circle, while FG is a line segment that connects G to exactly one point on the circle. Because of this, we're going to define HG as a tangent line. With similar reasoning, GF is also a tangent line or figure. In fact, F is the point where the tangent line FG intersects our circle, while H is the point where the tangent line GH intersects our circle. So now let's get into a theorem explaining the reasoning for this. So if two segments from the same exterior point are tangent to a circle, then they are congruent. Based on this theorem, our figure line segment FG is congruent to line segment HG. This means the measure of the line segment FG, which is 5x minus 9, equals the measure of the line segment HG, which is x plus 7. Now let's get into solving for x. So 5x minus 9 equals x plus 7. So we have to eliminate, we have to have x by itself. So we have to add 9 on both sides. So that would make it 5x equals x plus 7 plus 9, which is 16. So we want to get x by itself on both sides. So we subtract x on both sides. So that would make 5x minus x 4x. And x minus x would be 0, so 16 is remaining, so 4x equals 16. So we have to get x by itself, so we divide both sides by 4. And so 4 divided by 4 would be 1, which we leave it with x. And 16 divided by 4 equals 4. So in conclusion, the value of x is 4. So now we're asked to find each measure. So of measure of arc x, y. Here in our figure, we're looking for the measure of our figure of measure x, y. As we learned from our previous problem, xy is a tangent, which is a line that comes from an outside point that intersects a circle one time. Line WY is a secant line, and I'll get to that in a second. A secant is a line that goes through a circle and touches the circle twice, as you can see. W is 41 degrees, which is the angle between the tangent and the secant lines. 103 degrees is the measure of the arc XZ. Now, let's return to our figure before we look at our theorem today. XY is the larger intercepted arc in our circle. XY is an intercepted arc because endpoints are where the tangent and secant lines touch the circle. Our smaller intercepted arc in our figure is XZ because the endpoints of XZ is also where our secant and tangent lines touch the circle. But for now, let's get to page 761 to check out the theorem 11.14. If two secants, a secant and a tangent, or two tangents, intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. But let's now plug in the measures into our equation. So the measure of angle x arc xy minus the measure of arc xz times 1/2 equals the measure of angle W. 1/2 times the measure of arc XY minus 103 degrees equals 41 degrees. We're all done for today. Thanks for watching.